Hello everybody, it's Adam here coming back to you from Houdini 15, and today we're going to make a crumbling font effect. So we'll control click the font, we'll dive inside, we'll type the @ symbol, and for origin we're going to type 1.938, and then for font size we'll type 5. And that makes the @ symbol kind of rest right on the ground plane there. Let's drop down a divide. We're going to fill out the interior of this with better geometry. So we'll activate Bricker. For X size, we'll type 0.1, Y 0.2, and we'll visualize our divide here. And you notice we have a thin sliver here. So we want to avoid thin pieces if possible. So I'm going to type -0.1. That gives us a wider area here. Let's drop down Poly Extrude. Activate it, I'll kind of wheel out a little, and we'll set the distance to 0.5 and the divisions to 5, and we'll output the back. So the goal here is to have some square pieces going this way, some square pieces going this way. Now we want to have our smaller fracture pieces be in the center area of the A itself, and we can do that using a group. So we'll drop down a group. I'm going to rename it to Group via Sphere. We'll activate that, and we'll type a group name here, Fracture Points. And for entity we'll choose points. We'll disable number, switch to the bounding tab, enable it, and choose sphere. And the goal here is really to just kind of move the boundaries of this sphere around our central area so that we're encompassing as much of the geometry as possible here. And no matter what you do, let's see if we can get this out a little more. No matter what you do, you'll never get this corner. So we need another group. So we'll copy and paste this one, connect this in. Whoops, something happened wrong. Disconnect that. There we go. And this one I'll rename to Group via Box. We'll just change our bounding type to box. And this time we'll just get that area there. And you'll notice our box has some of these outside points in it, so we want to make sure we're not getting those by tightening up our bounding area. That looks pretty good. Then we'll switch our merge operation to union with existing, so it will add these points in the square or the box to the fracture points that the sphere captured as well. Okay, let's colorize them now. I'm going to drop down a color node, and the concept here is that we'll set this to black. We're going to make our own density attribute, and we'll use an Attribute Wrangle for that. Whoops, keep going inside. Use a couple lines of code. Float change chance equals random at ptnum semicolon. If change chance is greater than 0.5, so if that's a 50% chance, so half the time we're just going to add v at cd.r equals random at ptnum plus change chance. We're going to add a random red color half the time, and if we visualize that, you can see that's what we've got here. It's almost like a quick noise if you think about it. So we only want to affect this central area. That's where we want our smaller pieces, and that's where we're going to issue our scatters. So let's choose the group we created, and that gives us only red there. That's our density attribute. We'll drop down a scatter here. Visualize it, and we'll see the points take over the entire mesh, and we'll activate density, and that breaks the scatter because density as an attribute does not exist, but CD does. So we'll type that, And I'm going to lower the count to 128 so I can get quicker sims. And in your final production, you'll want this number higher. Let's drop down the Voronoi fracture at this time. Connect in from the group up above to the left, the scatter to the points to the center, and then activate the node. And when you activate the node, this can take a little bit of time depending on how many points you have. So keep that in mind. But basically that is, we're going to return to the obj level. That's our font object set up for fracturing. So let's switch to the rigid body tab and drop down a ground plane. Press the L key to lay out our network, and we'll press play, and we'll see nothing happens yet because our font object, we'll select it, is not participating in the simulation yet. Let's click RBD fracture and choose the RBD fracture object button. And now it's a participant. If we press play, we'll see gravity takes over. Now that we have all these pieces participating, let's glue them together. So we click the glue button and we'll read the message, select the RBD objects to glue together. Well, they're all selected, so I press enter. And we'll move over here and we'll press the L key to lay out this network. If I press play, you'll see nothing falls anymore because they're tightly bound by these red strings or threads. If we select the glue constraint, it's because of the strength, and this controls the binding of these red threads. So if I drop this down to 100, it was 10,000, you'll see basically gravity takes over again. So this is kind of like a way to scale gravity. At least that's how I think of it. It allows you to add a little drama to your fracture. So there's 360, you can see it kind of falls, it waits a second, and then pieces slowly crumble out. And look at that, it fell right towards the camera and broke apart. Now this did not break, so maybe we want to loosen it just a touch. I don't know, maybe we'll go down to say 290. Let's see what we get out of that. And when you change that number, you're going to change the sim. So if you find a number you like, remember it, write it down. And we'll say that's pretty good. You can play around with numbers all day. Let's go back to obj level. Rewind. And the next thing we want to do is add debris. So we'll click the debris button and it'll start cooking. And if we press play after it's done, we'll see that it's made a new sim here called debris sim, which just cranks out particles from the fracture points. But these are continuous particles, which is way too much for my taste. So I'm going to rewind and we will press the L key inside our debris sim to lay this out. Select the pop source and activate the birth tab. And this is the reason why. We've got 5,000 particles per frame. So we're going to zero that out, turn off constant activation. We're going to type an expression here for impulse. If, double parenthesis, $FF greater than 7 and $FF less than 48, comma 0, comma 1. So basically it's a switch that when the frame range is between 7 and 48, it'll be on, or otherwise it'll be off. Let's turn up our impulse count to say something like 90, just a small amount. So, and while we're here, let's activate the pop object, go to the physical tab, and this is where you can control bounce. So we'll set that to 0.18 so that particles won't bounce so much. Return to the object level and sim. You'll notice you get that burst of particles only when they initially break apart. Press the L key to lay this out. Now that we have a debris source here, we can use it with the PyroFX. So you can try flames if you wanted. I'm going to use billowy smoke here. With this selected, I'm going to control click on billowy smoke, and we'll wait for this to calculate away. And you'll notice we now have a Pyro solver inside our debris sim. Let's rewind and see what we've got. We get our particles, and now we get this fog and smoke rising up. So at this point, we pretty much have all the pieces that I want in place, or at least the setup is in place. Now we have these particles, and if we look at them, you'll see they're not really colliding with this ground plane, and we need to fix that. So we'll go up one level and dive into this debris sim here, and you'll see there's no collision plane. So what I've been doing is I'll just go into this AutoDOP network, which has a working ground plane static solver stack. I'll just copy that, dive into the debris sim, move my mouse down around here and paste that in. And then I'll connect this merge into that merge and make it the final output. Return back to object level, rewind and sim, and now our particles collide with the ground plane as it slowly crumbles down, and we get smoke rising. So what can we do to fix this up just a little bit more? And there's a couple things. Let's drop into shop and we can add some materials. I'm going to throw out two shaders here, principled shaders, and we'll call one inside and one outside. We'll say our inside is kind of a dark gray color, and we'll say our outside is kind of red. We'll return to the object level, dive into the font object, and let's do a little bit of fix up here after DOP import. Now we do have our inside and outside groups, so we'll drop down on material and we'll choose our group. We'll say outside is first here, dive into shop, choose that color, and then we'll add one more, select the two, choose inside, and we'll pick the inside color. And then when we visualize our material, you can see we have red on the outside and gray on the inside pieces. What else can we do? Well, if you think about it, let's take a look at our render here. I'm looking for a good particle. There we go, like say right there. We'll just throw a camera in for fun. Switch to render view, turn off preview, activate our camera, render away, and we'll click down around here to kind of, you notice our particles are just spheres. It would be nice if our particles were shards, you know, actual like chunks and debris, and we can do that. If you think about it, we have all these pieces here. Let's just map them right onto the particles, and we can do that inside of this debris object. We dive in, it's just a DOP import, right? So let's do an object merge, and we're going to merge in the font object, which has all those pieces in it. And then we're going to drop down a delete node, and if we middle click, we can see, I'm trying to see where they're at. Groups, inside, outside, primitive. I don't see my pieces yet, but that's okay. Inside here, we have 4,000 points in our stream. So we want to add an Attribute Wrangle again. And for this Attribute Wrangle, we're going to type int debris index, or this is max index. So we want max index to equal 90. If you remember, we had about 128, 162 particles or pieces in our fracture. And then we're going to say I at debris index equals random at ptnum, close parenthesis, times max index, semicolon. And that should give us a number randomly. Let's split top bottom here. Go to the geometry spreadsheet and see if this is actually working for us. What would that be called? We called it debris index. So debris, we may have to rewind to see this, or maybe we have to visualize to see it. Dead, where is our debris index? We'll press play. Let's make sure our code is right. We need to spell this right for one thing. Doesn't really matter as long as you reference it correctly. Warnings encounter. Implicit cast from float to int. Okay, so we probably have to wrap this whole thing in an int. And now that warning message goes away and our debris index shows up. So you can see we just got an index into what we're going to choose for our delete. And if we go to our delete and activate it, you can see we've merged in all of our pieces, right? So what if we just type, we can't type that yet. Let's just see piece 0. And let's see what it says. Piece 0 is not a valid group. Let's jump back up here into our font object and see what's going on. Did we set that up under group? We did not. So we have to add the group prefix here. And now if we kind of rewind and resim, we'll jump into debris again. We can see that if we delete non-selected, we should have one piece, and we do right there. It's piece 0. So you probably guessed it, we can just do a copy at this point. We'll put our points in on this side, and I know I'm going to need to make these smaller, so I'm going to add a transform. Put that over here, visualize our copy. And under the stamp tab here, we'll activate that. And our attribute we want to stamp is debris index. And you can see we've got this massive amount of just junk now. Let's customize this group here with a backtick stamp. Quote dot slash copy 1 quote comma quote debris index quote comma 0 close our backtick. Now you can see we get different debris pieces from our copy here. And if we go to transform and set our uniform scale to what, maybe 0.2, and we'll wait for the stamping to occur. And now you can see we're basically using these same pieces to be debris elements. And we might even want to go smaller, like 0.7. Something like that. And this will make your sim much heavier because we're stamping thousands of particles basically every time we move to a new frame. It's not the most elegant solution, but it does actually work. And now if we issue a render, we're going to expect that these little spheres are now going to be replaced with these smaller chunks, and they are. And that is pretty much it. I guess we could wait this out here. Let's see if I can get a full-blown... I don't think we're going to be able to get a full-blown real-time sim because of the stamping. So if I were to turn off the copy and continue through the sim here, I'm going to close this down. And we'll stop at a lower frame here, say 40 or maybe 96. Kind of mouse wheel out. You can see we've got debris emitting. Our font is crumbling, smashing apart. And we know we can turn on our copy to replace these particles with additional pieces from the font itself. And let's watch our frames per second. I don't know what I'm going to get. It's close to real time. Not too bad. And with that, I'm going to sign out.